Today we discuss chapter 2, electrostatic potential and capacitance. So here chapter number 2 is electrostatic potential and capacitance. First here we discuss about electric field. I summarize electric field. If there is an electric charge, then there is an electric field. That means electric field, that means due to charge. If there is a charge, then there is an electric field. And electric field measured in two ways. First one is a vector measurement. Vector measurement of electric field is electric field intensity E, and scalar measurement of electric field is electrostatic potential V. Here is the electric field due to charge. If there is a charge, then there is an electric field. Electric field measured in two ways. Vector measurement of electric field is called electric field intensity. This is discussed in first chapter. And the scalar measurement of electric field is electrostatic potential, or simply it is known as electric potential. In this chapter we study electrostatic potential and the capacitance. Now some note here. First one is the if there is a electric field, then there is electric charge. Second one, if there is charge, then there is electric field. Third one is the electric field measurement in terms of electric field measured in terms of electrostatic force is called electric field intensity. Electric field intensity E is equal to F by Q naught. And the fourth one is the electric field measured in terms of work or potential energy. Electric field measured in terms of work or electrostatic potential energy is called electric potential. Electric potential V. V is equal to W by Q naught, where Q naught is the test charge. First topic in this chapter is electric potential. Electric potential V. It is also known as electrostatic potential. Electrostatic potential at a point in the electric field is defined as the work done in moving a unit positive test charge from infinity to that point in the electrostatic field of the source charge. That means if there is a source charge, then there is a field around it. This one is the electric field region. Now this one is the infinity, and here a point P where we have to find the electric potential, and this plus Q is source charge. That means if there is a source charge, then there is a field. This one is the field region, and in this field region there is a point P where we have to find the electric potential. Definition of electric potential is that it is electrostatic potential of any point inside electric field is defined as 2 moving a test charge from infinity to point where we have to find the electrostatic potential. This one is the infinity. If W is the work done to moving a test charge from infinity to point P inside the field, then electrostatic potential or electric potential at P is given as Vp is equal to W by Q naught. What is the unit? Joule per coulomb. It is also known as volt. Electric potential at any point in electric field also defined as the electrostatic potential energy per unit test charge. There are two definitions of electric potential. First definition is electric potential of any point inside the electric field is defined as the amount of work done to moving a unit positive test charge from infinity to that point. And the second definition is the electric potential at a point in an electric field is defined as the electric potential energy per unit test charge. If U is the electrostatic potential energy of test charge Q naught at a point P, then electric potential at P, Vp is equal to U by Q naught. That means there are two expressions. In terms of work, potential is equal to work upon test charge, and in terms of potential energy, here potential energy divided by test charge. Unit is joule per coulomb or volt. Now some note related to electric potential. First one is the electric potential is a scalar quantity. Electric potential is a scalar quantity. Second one is its SI unit. Its SI unit is joule per coulomb or volt. Now here 1 volt is equal to 1 joule per coulomb. By definition of electric potential, V is equal to W by Q naught. If Q naught is equal to 1 coulomb and W is equal to 1 joule, then V is equal to 1 by 1 volt. V is equal to 1 volt. Now here definition of 1 volt. Electric potential at a point in the electric field is 1 volt if 1 joule of work is done in moving 1 coulomb charge from infinity to that point. Again here we repeat, electric potential at a point in the electric field is 1 volt if 1 joule of work done in moving 1 coulomb charge from infinity to that point. Third one is the CGS unit. CGS unit of electric potential is state volt. State volt. Now relation between volt and a state volt. Relation between volt and state volt. 1 volt is equal to 1 joule by 1 coulomb. Now joule in erg, that means joule in CGS, here 10 to the power 7 erg, and 1 coulomb in state coulomb is 3 into 10 to the power 9 state coulomb. Now here 1 coulomb is equal to 3 into 10 to the power 9 state coulomb. Now we solve, here we get 1 volt is equal to 1 divided by 300 state volt. State volt. So this one is the relation between 1 volt and state volt. Next one is the electric potential. Electric potential at infinity taken as 0. Electric potential at infinity taken as 0. That means at V infinity is equal to 0. Next one is the electric potential due to positive charge is positive and the electric potential due to negative charge is negative. Electric potential due to positive charge is positive and electric potential due to negative charge is negative. This one is the concept of electric potential. Next topic one is the electrostatic potential difference or potential difference simply. Now here potential difference. What is the concept of potential difference? Here we take a source charge. This one is the source charge. If there is a source charge, then there is an electric field around it. That means there is a electric field around it. And now here we take a line up to infinity. This one is the infinity. At infinity, electric potential is 0. Now here we take 2 points. This one is the point A and this one is the point B. We have to define here potential difference between A and B. What is the definition of potential difference? Potential difference between any 2 points inside the electric field is defined as amount of work done to moving a unit test positive charge from one point to another point. For example, here we have to find the potential difference between A and B. That means here we have to found work done to moving 1 coulomb charge from A to B. Let VA is the potential at A and VB is the potential at B. Let WAB is the work done to moving a test charge Q0 from A to B against the electrostatic force. From figure, if a test charge Q0 move from infinity to A, when this charge reached at A, then it experiences a electrostatic force, because test charge is a positive charge and this one is a positive charge. This positive repel to this. There is an electrostatic force. That means charge comes in left side and the force in right side. Hence we have to work done against this force. This work is stored in form of electrostatic potential energy or work. Now potential difference between A and B, that means delta V, VB minus VA is equal to WAB divided by Q0. A point near the source charge, have higher potential if source charge is positive. If source charge is negative, then for near point potential is lower and for far point potential is higher. This one is the expression for potential difference. That means here we found WAB is equal to Q naught VB minus VA. This one is the expression, and there are lot of numericals based on this expression put up in board examination. Potential difference in terms of electrostatic potential energy. Let UA is the potential energy at A and UB is the potential energy at B. Then potential difference between A and B is given as VB minus VA is equal to UB minus UA divided by Q naught. SI unit of potential difference is also bold. SI unit of potential difference is bold. Now here is a numerical problem. This one is the source charge and here point B and here point A. And what is the sign of VA minus VB? VA minus VB. Solution here. Since B lies the near of source charge and the source charge is a positive, that means potential at B is greater in comparison to potential at A. Since B is near to plus Q, that means source charge, hence potential at B is greater than potential at A. That means VB is greater than VA, hence VA minus VB is equal to negative. And the second question is, if source charge is negative, and here B and here A, then what is the sign of VA minus VB? VA minus VB. Since B is near to minus Q, this one is the source charge, hence VB is less than VA. That means VA minus VB is equal to positive. So these are the numerical put up in board examination. Now here next topic one is the electric potential due to point charge. Electric potential due to point charge. If there is a point charge means source charge. If there is a source charge, then there is a electric field. Scalar measurement of electric field is called vector. By definition of electric potential, it is defined as amount of work done to moving a unit positive test charge from infinity to that point where we have to find the electric potential. Now here we take a positive test charge, positive source charge. This one is the source charge, and this one is the line up to infinity. At infinity, electrostatic potential is 0. Now here we take a point A, here point B, and this separation is small r. Here we have to find the potential at B. We have to find potential at B. Now we move a test charge from infinity to point B. First this point reached at A. When this test charge reached at A and this one is a positive, then this positive repelled to this by a electrostatic force, and this one is taken X. If this test charge move toward the B, that means opposite to this force, then we have to work done. We have to work done against this force, and this work per unit test charge is called electrostatic potential or electric potential. Now this one is the vector dx and this one is the vector f. Let test charge reached at A, where this one is the O, where OA is equal to X. Then force of electrostatic repulsion F is equal to 1 divided by 4 pi epsilon naught Q naught X square. This one is the along right direction. Let dx is the small displacement opposite to force F. Hence we have to work done against a repulsive force. This one is the dw is equal to F dot dx. Now here F dx cos 180 because force and dx opposite. That means this angle is the 180 degree. Now here minus F dx. Now we substitute the value of F here. Minus 1 divided by 4 pi epsilon naught Q naught X square dx. Now here dw is equal to minus Q naught divided by 4 pi epsilon naught X to the power minus 2 dx. Now total work done to moving charge from infinity to B. we integrate this work above limit infinity to r. Hence, total work done to moving charge from infinity to b, that means r, w is equal to minus q naught 4 pi epsilon naught taken outside here infinity to r x to power minus 2 dx. Now here w minus q naught 4 pi epsilon naught here x to power minus 2 plus 1 minus 2 plus 1 and the limit infinity to r. Minus 2 plus 1 gives minus 1 and this minus and minus became plus. That means w is equal to q naught divided by 4 pi epsilon naught. Here x to power minus 2 plus 1, this became x to power minus 1. That means 1 upon x. This was the infinity to r. W is equal to q naught 4 pi epsilon naught. Now 1 upon upper limit is r. The upper limit is r and 1 minus 1 upon lower limit and the lower limit is infinity. Then here w is equal to q naught 4 pi epsilon naught 1 upon r minus 0. W is equal to q naught 4 pi epsilon naught 1 by r. Now by definition of electric flux, by definition of electric potential V is equal to W by Q naught. Now substituting the value of W from here, Q naught divided by 4 pi epsilon naught R divided by Q naught. This Q naught cancel. Here 1 divided by 4 pi epsilon naught Q by R. This one is the expression for electric potential due to point charge. Now from this expression it is clear that electric potential is inversely proportional to R. Now here curve between V and R, here we take V, here we take R, and V is inversely proportional to R, that means curve is hyperbola. So this one is the curve between V and R. Note here, first one, if source charge is positive, then electric potential V is equal to 1 divided by 4 pi epsilon naught plus Q by R. Second one, if source charge is negative, then electric potential V is equal to 1 divided by 4 pi epsilon naught minus Q by R. Hence we say that electric potential due to positive charge is positive and the electric potential due to negative charge is negative. At infinity, R is equal to infinite, then V infinity is equal to 1 divided by 4 pi epsilon naught Q divided by infinity gives 0. Hence electric potential at infinity is 0. There are some numericals discussed in PDF. In PDF there are three numericals. First numerical is in PDF. First one is the find the electric potential at a point when a work of 2.4 into 10 to the power 5 joule is done to carrying a charge 5 into 10 to the power minus 19 coulomb to that point. Here given W is equal to 2.4 into 10 to the power 5 joule, and to carrying a charge that means test charge. So now here test charge is Q naught, and this one is the given 5 into 10 to the power minus 19 coulomb. Now here we have to found the electric potential. Then by definition of electric potential, V is equal to W by Q naught, 2.4 into 10 to the power 5 into 10 to the power minus 19. If we solve this, we get 4.8 into 10 to the power 13 volt. Now second numerical is if 100 joule of work must be done to move an electric charge of 4 coulomb from a place where potential is minus 10 volt to another place where potential is V volt, find the value of V. In this problem, there one is the source charge, here is the source charge, and this one is the point A, this one is the point B. Potential at A is given 10 volt and the potential at B is given V volt, and the amount of work done from A to B, that means WAB is given 100 joule, and test charge is given 4 coulomb. Then by definition VB minus VA is equal to WAB divided by Q naught. Now substituting the values here. What is the value of VB? VB is equal to V and VA is equal to minus 10. That means V minus 10, 100 divided by 4. Now this one is a 25 and V plus 10, that means 25, and V is equal to 25 minus 10, that means 15 volt. From this numerical, it is clear that B near to source charge and B have potential 15 volt and A have potential minus 10 volt. That means a point near the source charge have higher potential. Third numerical in PDF. Calculate the work done in bringing a charge 1 into 10 to the power minus 9 coulomb from infinity to point distance 3 centimeter from a point charge. Here bringing a charge 1 into 10 to the power minus 9, bringing a charge, that means test charge. So now here given test charge is equal to 1 into 10 to the power minus 9 coulomb, and source charge is given 2 into 10 to the power minus 6 coulomb, and distance is 3 centimeter, that means 3 into 10 to the power minus 2 meter. Now here we have to found work done. For work done, first we calculate electric potential. By electric potential due to source charge V is equal to 1 divided by 4 pi epsilon naught q by r, 9 into 10 to the power 9, and the value of q is 2 into 10 to the power minus 6, and the value of r is 3 into 10 to the power minus 2. If we solve this, we get 6 into 10 to the power 5 volt. Now V is equal to W by Q naught. Therefore, W is equal to Q naught V. That means 1 into 10 to the power 9. Value of Q naught is 1 into 10 to the power minus 9, and the value of potential is 6 into 10 to the power 5. If we solve this, we get 6 into 10 to the power minus 4 joule. Mazhar